on the mint function. We got it to run, remember? So let's just try to do it again, just to make sure that it still works. It kind of downloads all the stuff. We'll open it in a separate window, close this thing here, and there you go. So you connect the wallet. I'm just gonna take it off the screen. See if I can unlock these. Awesome. Okay, so actually the contract is deployed okay, because that's the test net and the contract is there deployed. And so there's no, well, the mint function is the one that we created, right? Now I wonder why is it that the standard doesn't have a mint function? You know, that is kind of, let's see. So, why doesn't function? There you go. I mean, there's definitely a private method, right? But or why is mint private method? Before I make some weird kind of decision, most of the examples use open separate NIC require the main function to have an access control where only the owner see, but I don't see that function here. Oh, so this one does. Or what is the point here? Or is it that it's another contract? Preset minter pauser auto ID. It seems like there's some kind of design pattern used here that it's owners, balances. Okay, so the standard does not define the best or correct way to mint new tokens, such as whether it should be open or restricted, and it's up to each contract developer to implement or omit the minting feature in a way that reflects their needs. So creating NFTs and destroying NFTs is not included in the specification. Your contract may implement these by other means. Please see the documentation for your responsibilities when creating or deploying NFTs. Okay, fair enough. So, knowing that, it means that we are fine to kind of just use, build that, right? Now, so what do we have? So what? Let's say let's think about this. So what we're gonna do is we want to have the kind of like people uploading videos like these, right? And we want to have kind of, let's forget about the content for a second, but what we want to do is we want to give a content ID and then kind of try to make sure that the content is unique in a way, right? So, because at the end of the day, what we want to do is generate a unique token ID. Or let's say, what is mint doing? Here, safe mint versus mint. So safe mint versus mint. What is safe mint versus mint? So so the safe mint flavor of minting causes the recipient of the tokens, if it is a smart contract, to react upon receipt of tokens. If you are paying for the minting of tokens, use mint. The safe mint might cost you an arbitrary amount of money because of choices made by the recipient of tokens. This is enough to deter you from considering it. If they are paying for the minting of tokens and you expect buyers to be composing functionality with smart contracts, use safe mint. This is some marginal benefit of allowing extra features. If they are paying and you expect individual people to buy tokens, then use mint. The extra features in safe mint are not expected. It's non-zero, okay. Check on ERC721 received. So it's calling a function. Now what it does is, okay, invokes. Okay, so what this does is it invokes some kind of some kind of functions on the receiver. So what it does is from to token ID, and then if to is contract, so if it's not a contract, return true. So there's just no point. The point is if we want real people to be minting, then that will just, it's unnecessary to call that because it will just returning true and it's just extra gas cost. But if it's a contract, what it does is it calls this function, which probably basically, you know, kind of, what does it do? I don't know. Revert. I have no idea what revert is, but it does something. Oh no, that's catch. Okay, return. It just returns these. Okay, so it returns something. Like the receiver is like a, I guess is so it says the contract does something, then it returns a value to you, and then what this does probably is well, essentially, oh, that's a safe transfer, safe mint. It does nothing with this value, I guess. It still calls mint, but it calls these, and then you can probably do something with this value, I guess. So we don't care about that. So we only care about mint. Okay, so we're gonna use mint underscore mint. And what underscore mint does is where am I? Oh God. How can I search for a function? Safe mint, mint. Is it that mint is just in the, oh, there it is. Okay, so what it does is require that the address 0 is not the one that is you're minting to, and then you need an integer that's a token ID. Okay, so we need to generate a token ID. Require that the token ID doesn't exist, and executes the before token transfer, then adds the balance, adds the owners of this ID. So we have balances and owners. And then it emits the transfer thing, and then it does after. So, and these things basically, what are they? Currently they're just empty. They're just hooks that you can, okay, cool. So we need basically, what do we need? So we need So this is the public. This is the public main function. What is @def? I don't know how to write proper comments, so this is the public main function. And what it does is and so what it should do is it should actually get it gets the content ID, right? Now the question is, how can how does IPFS deal with duplicated content, for example? Scenario, yeah, duplicate content. Okay. Okay, so actually it does do some kind of hashing. So identical copies, at least this is something that we've got already then covered, because it means that we are getting if I add identical copies of the file or some data to IPFS twice, it returns the same hash twice. It does not store the file twice. No, does erase an error. If you're building a system where people need to be able to claim some sort of identifier or namespace, preventing others from using that identifier or namespace, you need to handle that on your side. One option is to use IPNS. Another popular option is to put the info on the blockchain like Ethereum. Exactly. So if someone has already claimed the content ID, it means, you know, that's the thing, right? Yep. So basically it's, yeah, what is the content ID, right? So the content ID, copy the content ID. It's a string, right? It's a string. And I need to make a unique token ID out of that, I guess. Solidity, maybe there's something already there that I can reuse. Solidity, unique token IDs from IPFS content IDs. How do I say this? Permitted token. That's what we want to do. Try to sense market development. It's not the field of me that I just JSON file in the rain, but I have hard time figuring out how to get them into the contract. Set URI. Okay. Pretty pricey. ID substitution for token URIs. You should be able to follow the approach described in that thread. Pinat allows you to upload the directory with your images and will give you the IPFS link to use as base URI. using counters. Because that would be, the ideal thing would be to turn that into an int, because into token ID, because yeah, but how do you guarantee that it's unique? You really don't. Unless we would concatenate stuff, like we would start with, say, 1, and then we would concatenate that with whatever the number sort of the mapping gives us 2, and then we know, but that's also not good either. Because another option is to keep what they're saying here, right? Keep a separate list of CIDs, right? How to say unique IPFS CIDs per minted token. Fetch IPFS data and smart contracts in Chainlink. The Otis API. Boo, that's actually pretty. Chainlink. Create an NFT and upload your metadata to IPFS. So what do they do here? So CIDs, you identify a piece of content. You store it and send it over the network compact binary form. Example, okay. URI, getaway, metadata, and availability, summary. That's not what I want to do. Because the typical use case is you have already a so you have a you basically have, what if I just hash it? What if you just hash a string? What if you just number from a string? Why? I mean, I think I could just do that. Yeah, exactly. You can use unisolated type, including strings and arrays, to generate bytes and hash. From here, you can either just use the bytes as the result, or as a key, or cast it into a uint. So can I do something like that? So we're gonna have basically a for some reason the string thing needs the memory, right? Using strings. String private, string memory, right? Yeah. So I don't know what this modifier is though. So we're looking for the token ID, right? So we're gonna say token ID equals this function, and then, well, here we just will have a string memory seed. And then, so this will just be a hash of these. Hopefully that's not too expensive. And then, do I need to cast like something like this? Casting in Solidity works like this. I don't know. Solidity type casting. How does it work? Okay, so just, okay, so it's the other way around. So it's like so you just do like that. Token ID, and now we'll say mint, and mint has a to address and a token ID, and let's see if that works. Solidity. I don't know, I can just use that hashing functions in Solidity. $64 characters. I think it's definitely an auth. Oh no, but that actually hashes it like this. I want to hash it into an integer. So it's definitely not an integer. Oh, maybe I can just cast it. Can't I just cast? So Solidity. Cast string memory address to uint. String to uint. That seems too complicated. To be honest, I don't know. I think it's yeah, but I don't want to have to check on uniqueness, right? That's the point. I don't want to have to check on uniqueness, like that I have a list of things and then make sure that when someone tries to mint something else, make sure that this is not there. Although, how do they do this? There's this kind of require in the mint. Require save mint. What is a save mint? Save mint. Require no mint exist token ID. What does exist do? Returns wait a second. So you give it a token ID and then check the owners. I guess why can't I just turn that into a string? You know what I mean? Use that token ID to be the CID actually. Can I just make that modification, or is it the mint? I think the mint requires this to be a uint. That requires to be an integer. Okay. So I think it's just. I think what I should do probably is we have the. So we have the owners. And it's checking that there's no, that this uint doesn't have, that this thing doesn't have any owner. Exactly. So I should probably have another mapping. Then maybe we'll just do it like this: mapping from IPFS CID to maybe also to just owner address. Right. just the owner. Not like I could map it to IDs. Maybe two IDs actually, because I need to map it to token IDs. Because I wanna make sure, and I call these like CIDs. I wanna make sure. Cool. And so require exist. So I want to make sure, and I'll do that in my, of course, mint function, right? So because I have the CID, and I wanna, how does this require work? Do I just put it in? Yeah, it's just a statement. So I just say require that that not CID exists, and then we give it the CID. CID already minted, and so the exists function, which is this one here, I'm gonna copy, and I'm gonna put it in here below, and I'm gonna just say so CID exists. I think that's the pattern they use for that. CID exists, and then it actually has a string memory, and it's the seed, and so we want these to be return seeds seed, and it's not, it's there's an address. Index exists. How can I check, like in Solidity? Check if array key exists. Do we have that? Explicit exists. Come on. Well, I can actually just do something stupid, which is different than 0, say, because so maybe the assumption would be token ID 0 won't ever exist, and so you just check whether, you know, and if that basically breaks, because I mean, how does this even work? I mean, if the token ID is not existing, right, that require, isn't there a way to just find the functions better? What it does is return whether, so is this different than address 0 token ID? Wait, is it because the owners is pre-populated thing? Owners, private owners, constructor, no. Owner off. The mean function actually it just adds that address, and so it's okay. Let's see. I don't know if that will work. I'm confused because I don't know if it's got a fix. If it's something like you're just exploiting the fact that if the key is not going to be there, then this is going to return something else that is different than 0, or basically exists. That's the thing. Maybe it returns. I don't know what it would return, right? Like if it exists, it would return the token ID. If it doesn't exist, it would return maybe false or something like that. Solidity handling key doesn't exist. In a mapping. Oh, bytes. So simple mapping address to string, I can check if is a key in this mapping, and if it is, get its value. If it isn't, I should return something. So what it does is, if this doesn't work, check if the length of the bytes. So if bytes, interesting. Okay, so you can do it like that, but let's do it like this: bytes equals 0. So return bytes of this doesn't equal 0, so then it exists, right? So if the bytes are not 0, then it exists, and then we require for this not to exist. Okay, cool. So now we should kind of create a token ID. So how do we create unique token IDs? Solidity. Is it just some kind of counter or something? Solidity counter or something like that. Because I can just solidity increment counter, contract counter. I don't want this to be a counter, but I guess it's just simple, right? So basically what I should do is sort of increment counter, increment token ID counter, then sort of current token ID. At least that just increments it all the time, right? So what this does is function, it assumes there's some internal property, so this has nothing really, and then what it does is increment token ID counter. I don't know if that's safe. I think it's kind of okay, right? If it doesn't, if this doesn't get executed or something, I think nothing really bad would happen. I don't know. And then so we current token ID. So what I have to do is just define that as a so it's not current, it's like last used token ID, and that's going to be a uint 256 private, and we'll call it last token ID. And so what these would do is actually increment token ID. So last token ID +1. This is increment. Do I have to actually have a separate function for this? Come on, guys. I know it's good practice, but I think we can just do it like that. So last token ID, so we increment the last used token ID and use this one. And then we mint it. Cool. That should be it, to be honest. Do I have, oh god, wait a second. Why am I, oh, there you go. Okay, so there's an error, mapping owners, blah, 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 blah. Okay, obviously I forgot a semicolon, as it is typically here, owners, CIDs, cool. Token ID. Undeclared, so I have to declare it somehow. Here I have to declare it. I guess I just do like that. Boom. Okay. Convertible to expected type. This a type string number is not implicitly convertible to oh, so I can't use type uint. Okay, maybe I just did something wrong, which is I defined the mapping wrong. Obviously, this is basically string to uint 256. To bytes memory. Type bytes memory. Explicit type conversion not allowed from uint to, so this gives you a uint. Should it just do like length or something like that? Let's just try. Let's just try. It's like if it's different than 0, it exists. I don't know. Let's see if that works. Okay. Okay, no errors. But I guess I have to deploy the contract again, right? Deploy. And so we're just doing the minting here, right? So we're minting and then giving this to an address. That's all we're doing. Then what we'll need to do is, if the mint is successful, and so this will probably do, then we can hook it as in the after the mint. Then what we'll do is, because this triggers an event, so then what we will do is we will call the coin contract and give that address mint coins for that address. Okay, there it is. What do we have now? Mint. Okay, so we have this and this. Let's see what happens. So I'm gonna try to mint something to my own address, and I'm gonna give the CID of this guy. CID. And I'm gonna run it. Requires gas. Oh yeah, I bet it requires gas. Okay, so the transaction's there. It's interesting because things can still fail, right? So you don't really know, like, how do I know if actually something went wrong? This is how do I even test that? I guess I can check. I guess I can check balance off. It says 1. Let's try let's try the following, and we'll leave it here, right? So I wanna have another function that says function how do I call it? CID, return CID, oh, get CID. So function get CID, and then you have a basically uint 256 token ID. This is a public function, and what this does is return sits. No, return. I have a token. So how do I know that? And I haven't even populated these. So I guess what I have to do is, after mint, is CID's CID token ID, and I want to check, given a token, the owner, no, given a CID, okay, so that's CIDs, that's fine. Given a CID, I want to see the token ID, that's fine. So actually I have to do that, and then what I need to do is return CIDs, and sorry, this is string memory CID. So I get the get token ID, get token ID by seed. I don't know, should I keep capitalizing the whole thing? Get token ID by CID. I probably have to have a better name for these. So I get this stuff. I mint it, and then I want to return the token ID of that CID. And so if I do the same twice, I should be getting the same token, right? So let's redeploy these. Error. There you go. Let's redeploy that. Error 476 here. Oh God, return CIDs. I have to returns. Come on. Is there like a get function? Get to no. Get approved. Returns address. Okay, so view, public view, whatever. So public view returns uint 256. There you go. We'll deploy the contract. That's really neat that it actually comes with all these different testing things here. Cool. And run the coffee. Deploying. Yeah, so that's what that's what I want to do is I want to call a mint function, and then I will call get the token ID by CID, and then I'll try to upload the same thing, see what happens. There it is, mint. So we'll actually get our address in here. We'll get our content ID, and run the thing. Approve, pay for this. There you go. And now we have, what do we have here? This is the new function we have. So first of all, balance off says 0, so still didn't, oh, there you go. Now, okay, now if I put in here my token ID, my CID, I'll get the token ID. Cool. It's number one. That makes sense. If I now, and I'm not validating these things exist, right? But let's say I want to mint and I do the same thing. So but I'll just kind of add 2 5s at the end and I'll copy my address. And so this is in theory gonna mint something else, right? We don't know whether the CID is a valid one or not. We don't care. We will have the validators for these. So the validators will just basically go and kind of will review that these are valid, and then that's what's gonna give the actual person the coins. So we will not actually, I was wrong when I said that, but anyway, so I should have 2 now, minted 2, which is correct. And if I get this token, oh sorry, so if I get this CID here, it gives me 1. If I add 2 5s at the end, it gives me 2. That's cool. And now if I try to mint, let's say the same thing, and I give it my address, and I run it, okay, execution reverted. So what it so actually it actually complains. Okay, CID already minted. That's nice. Okay. Cool. That's fine. I mean, that is actually totally fine. If I do that thing again, it also will break. Nice. But how did I? That's pretty actually unconsciously. Okay, because there's the require, and so it actually fails. Okay, fairly simple stuff so far. Cool. So I think we're done with minting. Yeah, we're done with minting. That's just the minting, right? Then what we'll need to implement next time is a mapping of validators. I mean, it's not a mapping really. Oh yes, it's a mapping of validators because we want to see which no, we want to just see it's a list of, we just want to have a list of validators. It's not going to be a mapping, it's just going to be a list. I don't know how to do that though, but then it's basically list of validators. It goes here, and so we're going to have we're basically going to have a function that is called to do validate, right? And so we'll have address validator. So the validator that wants to validate what do they want to validate? They want to validate a token ID, I guess, or oh, you know what? Actually, we can use that to be not these, but to actually be bools, right? So we want this to be okay. So that's what's going to tell us whether the CID is valid. Oh, but we still need okay. No, we still need to validate it. So owners, balance, token approvals, operator approvals. No, okay. So. We will have pre-owners and owners. We're gonna have pre-owners and owners, so basically to a pre-owner address. Pre-owner address, this means these tokens are not yet validated. But then this means our logic will actually have to be expanded and to say that the mint will also, to do check it's not in the pre-validated. Well, I mean, the CID minted, it's, even if it's pre-validated, that should cover for the pre-validation as well to do. does this cover for the pre-validation? Yeah, something like that. Anyway, I'll leave it here. But I think that's kind of the idea, right? So we have like we're gonna have this validate thing, which is gonna basically validate the stuff, and then we're gonna have another function that's also gonna be register validator, and that's gonna be an address, and that's gonna require stake ETH somehow. The ETH stays in the contract then, and that's going to be a complicated one. But we want the validators to have some skin in the game, so they're going to have to stake some ETH, you know, to be able to validate stuff. And if they validate the wrong stuff, then we'll take it from them. But yeah, how? I don't know. I guess all other validators can do that, right? But then you get into a bit of a, I don't know if the mechanism is good enough. We'll see. But I think that's probably the best that we can do. Cool. See you next time.